This is Algebra 2, Lesson 2-4, more about linear equations. Now, last lesson we learned how to write equations using the slope-intercept form. Today we're going to look at two other forms of writing equations, and you can interchange these forms all the time. Sometimes it will be easier to use something in standard form, and sometimes it will be easier to use something in slope-intercept form. If you're given the slope and the y-intercept, you can write the equation of a line in slope-intercept form. You can also write an equation in point-slope form or standard form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. You use this form when you know the slope and the y-intercept. Point-slope form is y minus y1 equals m times x minus x1. M is still the slope. x1 and y1 are the x-coordinates and the y-coordinates of the point that you're given. You use this form when you know the slope at one point or when you know 2 points. And standard form is ax plus by equals c. A, b, and c are real numbers. A and b cannot both be 0. This is very good to use when you want to find intercepts. Writing an equation given a point and the slope. If you're given a point and the slope, it's actually fairly simple to write the equation. Since you're given a point and a slope, you should use the point-slope form of the equation, which is y minus y1 equals m times x minus x1. So we have y minus y1 equals m times x minus x1. If it helps you not to make a mistake, write x1, y1 over your point so that you plug it in the correct fashion so that you don't mess up your equation. So if I was to do this equation, I would say y minus 3 equals negative 2/3 parentheses x plus 1, because minus a minus is a plus. Now to finish this equation, it is in point-slope form. So that would be the point-slope form of the equation. To write the slope-intercept form of the equation, all we simply need to do is we simply need to solve this equation for y, because this is the point-slope form. To get it into slope-intercept form, I'm going to take this equation, y minus 3 equals negative 2/3 parentheses x plus 1, and I'm going to solve it for y. So I will distribute first, so I have negative 2/3 x minus 2/3. Then I'm going to add 3 to both sides of the equation. Adding 3 is the same thing as adding 9/3, because I would like to use it as a fraction, so that I have a common denominator here. These will cancel out, and I will have y equals negative 2/3 x. Negative 2/3 plus 9/3 is positive 7/3. And that is slope-intercept form. So we have the point-slope form right here. We have the slope-intercept form right there. You cannot get the slope-intercept form without first doing the point-slope form. Let's look at the second one. Here we have the slope is negative 3, and we're going through the points 7, negative 1. So to do the point-slope form, okay, we're going to do y minus y plus 1. And remember, this is x1, this is y1, so it would be y plus 1 equals negative 3 parentheses x minus 7. This is point-slope form. So now if we just distribute, we have y plus 1 equals negative 3x plus 21, because a negative times a negative is positive. Subtract 1. Y equals negative 3x plus 20, and this is slope-intercept form. So here we have point-slope form and slope-intercept form of the same equations. Okay. This is point-slope form, and this is slope-intercept form. Now, if you're given 2 points and you need to write an equation, again, you can write it in point-slope form and slope-intercept form. The difference is if you write it in point-slope form, depending on which point you use, there could be 2 different equations, which is why I prefer slope-intercept form, because it doesn't matter which point you choose, Slope-intercept form will always be the same, regardless of which point you choose. So if I'm going to write the equation of a line in point-slope form and slope-intercept form, the first thing I have to do, I have to get the intercept. I have to get the slope. Okay? In order to use either one of those equations, we need the slope. So the first thing I'm going to do is I'm going to put my points over each other so I can find the slope. So the slope in here is going to be 1 minus 9 over 5 minus 7. So that's going to be negative 8 over negative 2, which happens to be a positive 4 for a slope. So there's my slope. So point-slope form now. Depending upon which point I choose, if I choose 5, 1, I'm going to have y minus 1 equals 4 parentheses x minus 5. If I chose the other point, I would have y minus 9 equals 4 parentheses x minus 7. Hence why I don't like using point-slope form, because there's always going to be two different equations you can have for point-slope form. For slope-intercept form, all I'm going to do is take either one of those points. It doesn't matter. I think I'll take the first one. So that would give me y minus 1 equals, I'm going to distribute that, 4x minus 20. If I add my 1 both sides, I'm going to get y equals 4x minus 19. So point-slope form are these two equations, either one. Slope-intercept form is this equation right there. Second example here, we're going to do the same thing. We still have to find the slope first. So I'm going to find my slope first. My slope is going to be 0 minus 7 over negative 5 minus 0. So it's going to be negative 7 over negative 5, which makes it positive 7/5. These equations are a bit more difficult when you have fractions. I'm only going to give one point-slope form. I could give both, but I'm not going to. It doesn't matter. So if I use the first point, I'm going to have y minus 0 equals negative 5 parentheses, excuse me, not negative 5, the slope in the wrong spot. Positive 7/5 parentheses x plus 5. There we go. I was putting my file in the wrong place. Okay, so point-slope form is that particular equation. Or you could rewrite it without the 0. You can have y equals 7/5 parentheses x plus 5, since the 0 will drop out. Slope-intercept form. I distributed that through. I'm going to have y equals 7/5 x plus 7. And that's slope-intercept form. All I did was take this second equation down here, distribute through, and I was done. Standard form of an equation. 99% of the time, standard form for the equation has to be written using integers, which means you can't have any fractions or decimals in your standard form of an equation. So you have to clear those. So the first thing I'm going to do if I have standard form is recognize the fact that standard form is ax plus by equals c. It has to be in that order. So the first thing I'm going to do here is I'm going to make sure that I'm in letter A here, I'm going to get rid of the fraction first. So I'm going to multiply everything by 5. I'm going to take this entire equation and multiply it by 5. That gives me 5y equals 2x minus 15. And if you have to, you might want to do this to make sure that every part of your equation is multiplied by 5, because people have a tendency to remember to multiply the first term and then forget all the other terms. Now I have no fractions, so the next thing I'm going to do is write it in the form for x to come first, then y, and then the constant term will be by itself. So I'll subtract 2x here, I'll subtract 2x here, you get negative 2x plus 5y equals negative 15. If you don't like the first term to be negative, you could rewrite that by changing all the signs. 2x minus 5y equals positive 15. Either one of those is acceptable. Notice we're using integers, no fractions, no decimals. In the second equation here, first thing I'm going to do is I'm going to multiply everything by 10. If I multiply everything by 10, I get rid of the decimals. So I now have 10y equals 91x plus 36. Move the x to the other side, so I'm going to subtract 91x. I have negative 91x plus 10y equals 36. If I don't want the first term to be negative, run a negative through to everything, so you get 91x minus 10y equals negative 36. Either one of these is acceptable, and they're both standard form of a linear equation. Now, graphing equations in standard form can be very simple if the intercepts are easy to find. Okay? Remember, the x-intercept is the x-coordinate where the line crosses the x-axis, and the y-intercept is the y-coordinate where the line crosses the y-axis. Okay? So if you have a line that crosses the axis, okay, where it crosses the x-axis, that's your x-coordinate of that point. Where it crosses the y-axis, that's the y-coordinate of that point. So the other coordinate should be 0. So to find your intercepts, the easiest way to find intercepts, find your x-intercept, plug in 0 for y, solve for x. Find your y-intercept, so plug in 0 for x, solve for y. Easiest way I do this to find intercepts, I go to the table, just put in the zeros. In this particular equation, 2x minus 4y equals 8. If x is 0, I'm going to have negative 4y equals 8. So if I divide by negative 4, y equals negative 2. So my y-intercept is going to be at negative 2. 0, negative 2. This is my y-intercept. And my x-intercept, find my x-intercept, I'm going to plug in 0 for y. So I'm going to have 2x equals 8 divided by 2, x equals 4. So those are my x and y intercepts. So I can quickly graph those. 0, negative 2 is here. And 4, 0 is here. And then I can draw my line. And of course, I shall label my line. 2x minus y equals 8. So, in this, the 0, negative 2 happens to be the y-intercept. Okay, so if you had to label your intercepts, this is my y-intercept, this is my x-intercept. And you can label them as points. 0, negative 2 is your y-intercept, and 4 is your x-intercept. Let's look at letter B. What are the intercepts in the graphs of 4x plus 3y equals 12? Again, I'm just going to make my little table. If x is 0, that means the x goes away. I have 3y equals 12, so y equals 4. If y equals 0, that means y goes away, so I would have 4x equals 12. 12 divided by 4 is 3. So my x-intercept is 3, 0. My y-intercept is 0, 4. So I can graph those intercepts pretty quickly. 3, 0, 0, 0, 4, 4. Graph my line. Label my equation. X plus b equals 12. Graphing by intercepts, as long as the constant term is divisible by both your a and your b, can be very, very quick. They're probably one of the easiest ways to graph, provided your graph ends up to be a whole number, or at least a fraction that's easy to graph. Let's say we need to take a real-world situation and be able to draw a graph from it and interpret that graph. The cost of a taxi ride depends on the distance traveled. The farther you travel, obviously, the more it's going to cost you. You paid $8.50 for a 3-mile ride, while your friend paid $18.50 for an 8-mile ride. What graph models the situation, and what is the equation for line in standard form? Okay, so it says the cost of a ride depends upon the distance. So the cost is dependent. So the cost is the y. Okay. Cost is my y. So which means distance is my x. Okay. So if knowing this, I can now put these in coordinate points. If cost is y and distance is x, 3 is my distance, that's my x coordinate. 850 was my cost, so that's my y coordinate. There's 1 point. My second point, 8 was my distance, and my cost was 1850. So there's my second point. I now have 2 points. I can find the slope, and I can write an equation on this. Okay, so the first thing I'm going to do is find my slope. So in this case, 8.5 minus 18.5 divided by 3 minus 8, which is going to be negative 10 over negative 5, which equals 2. So my slope is 2. Okay. So if my slope is 2, I can use either one of these points. I'm going to use the smaller one because it's just easier to use smaller numbers. So I can say y minus 8.5 equals 2 parentheses x minus 3. Solve this in slope-intercept form first so I can transfer it to standard form. So y minus 8.5 equals 2x minus 6. Add the 8.5. And I now have y equals 2x plus 2.5. To get that into standard form, get this into standard form, let's move it up here. Standard form would be negative 2x plus y equals 2.50. Now this is one of those rare occasions where it's okay to leave it in a decimal form because it would be really quite obnoxious to try to multiply everything by 100 or even 10. So then you'd end up with negative 20x plus 10y is going to equal 25, and that's a little harder to graph. So, if we're going to graph this, first thing I need to do is label my graph. Here, this will be miles, or distance. This would be cost. I'm going to graph by ones, and I'm going to graph using the standard form, or excuse me, slope-intercept form. So my y-intercept is 2.5. Or I could just graph the points. You can graph the points because you have the 2 points. It's pretty simple to graph the 2 points. I could say 3, 8.5. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8.5. There's 1 point. The second point was 8, 18.5. Would be up there. Okay, or I could take my first point, 3, 8.5, and I can apply my slope up 2 over 1, up 2 over 1. There. And then I can draw my graph that way. It doesn't really matter. You can draw your graph in so many different ways for this particular equation. Graph here. There we go. Graph. Pop that in place, and I can label it. And this is the graph of. Kind of doesn't matter which way I label it. I can label it in the standard form, like this right here. I can label it in the slope-intercept form. I'm going to label it in the standard form. The 2x minus y is negative 2.5. And notice I changed it to the first term of the following. So there's the graph that models the situation. There's the equation in standard form. And we could interpret it further so that you can determine how much it's going to cost depending on how many miles you drove. The last thing we're going to talk about are parallel and perpendicular lines. The slopes of parallel lines are equal. If lines are parallel, they have to have a different y-intercept. Notice they have a different y-intercept, but the same slope. And they will be parallel. They will never, ever touch. the slopes of perpendicular lines are negative reciprocals of each other. Notice this slope is negative 3/2, this one is positive 2/3. When you multiply them together, they have to equal negative 1. That's what this is saying right down here. We've done this in Algebra 1, we've also done this in geometry quite a bit. So, writing the equations of parallel and perpendicular lines. So if you need to write an equation of a line that's parallel or a line that's perpendicular, that just helps you be able to determine the slope. Okay? We're going to write the equation of a line parallel to y equals 5x minus 4, but going to the point negative 2, 1. And we're writing it in slope-intercept form, which means we have to use the point-slope form to get to the slope-intercept form. Since it's parallel, the slopes are going to be the same, so my slope is going to be 5. So I'm going to do y minus 1 equals 5 parentheses x plus 2, because I use this point, I use this slope, and I just simply write my equation now. So now I'm going to simplify this. Y minus 1 equals 5x plus 10. Add 1. Y equals 5x plus 11. And there's the equation of the line that's parallel to y equals 5x minus 4. Notice they have the same slope, but a different y-intercept. Let's look at our second problem here. The second problem, we're going to do a line that's perpendicular to y equals negative 2x plus 3/4, but has the same y-intercept as x plus 3y equals 12. So the first thing we have to do is figure out the slope. The second thing we have to do is figure out what the y-intercept is. So let's look at this. This equation here, the slope is negative 2. So the perpendicular slope has to be a negative reciprocal of that. Remember, a whole number is always over 1. So the perpendicular slope is positive 1/2. So the slope I'm going to use for my equation is positive 1/2. Use positive 1/2 slope because that's the slope we need. Now we need to determine the y-intercept. Okay, so let's take this equation here and let's figure out its y-intercept. Okay, remember, to figure out the y-intercept, you let x equal 0 and solve for y. So I would have 3y equals 12 divided by 3, so y has to equal 4. So my y-intercept is, oops, not 0, 0, 0, 4. So the point I'm going to use then, is 0, 4. So there's my point, here's my slope, I can write my equation. So y minus y1 equals m x minus x1, so I'm going to be simply plugging in this equation. Y minus 4 equals, my slope is 1/2 parentheses x minus 0. So y minus 4 equals 1/2 x, because 1/2 times 0 is 0. Add 4 on both sides. We end up with our equation being y equals 1/2 x plus 4. And that is the equation of the line that is perpendicular to y equals negative 2x plus 3/4 and has the same y-intercept.